Hello friends, today I will discuss about how to calculate different zone settings of a distance relay. Now what is the philosophy of distance relay? That relay will send a drift signal to the circuit breaker. Now distance relay is other name is impedance relay. That is a certain impedance is set in the distance relay. Now a diagram is shown in this figure. Here ZS is the source impedance and Bs is the source voltage. Now ZL is the line impedance and Z load is the load impedance, and fault occur at point F. Relay will sense a voltage of VR and current IR. The relay will measure impedance that is given by ZR equal to VR by IR, or it can be said the faulted impedance measured by the relay, that is ZF. The relay will operate or send a drift signal if ZF is less than Z. Z is the setting of the distance relay. Now a diagram has been shown for a transmission line network. In this diagram there are 4 substations. Substation A and substation B, there exists one double circuit line of length 100 km. And substation B and substation C, there exists one double circuit line of length 100 km, and between substation B and D there exists one double circuit line of 50 km, and in between substation A and substation C there exists a double circuit line of 50 km. All the transmission line of Panther conductor. And in substation B substation there exists 100 MVA transformer capacity of 132 by 33 kV with percentage impedance of 12.5%, and substation D and also 100 MVA of the same rating with same percentage impedance exists, and also in substation C. Now I want to calculate the different zone setting in a distance relay of MICOM P442 at substation A for transmission line AB. Here the different parameters for 132 kV transmission line of Panther conductor has been shown in this table. Here R1 or X1, B1, R0, X0. R0 are the zero sequence resistance, X0 is the zero sequence reactance, Xm is the mutual reactance, X0m the zero sequence mutual reactance, and R1 is the positive sequence resistance, and X1 is the positive sequence reactance, has been shown in this figure. The CT ratio at substation A end is 800 by 1, and PT ratio is 132 by root 3 kV, and secondary is 110 by root 3, that is 63.5 volt. Now what is the zone 1 setting? Zone 1 is the setting is given to cover 80% of the line segment. Now line length is 100 km, and positive sequence resistance is 0.14 ohm per kilometer, and reactance is 0.4010 for 132 kV double circuit single Panther conductor. Since it is a double circuit line, we will take the value of R1 as 0.14, and for X1 is 0.4010 ohm per kilometer. So zone 1 setting is given by zone 1 equal to 0.8, that is 80% of zone 1, 0.8 into 100 km into 0.1400 plus I into 0.401. Now this value is the primary value. We have to convert it secondary value to calculate the setting for P442, because MICOM P442 relay only understand the secondary value of the relay. It will automatically convert it by primary value by means of CT ratio and PT ratio, and check the actual fault impedance in the primary value. Now how to calculate or convert the setting from primary to secondary value? Now if the ZP is the primary impedance and ZS is the secondary impedance, we require the CT ratio and PT ratio to convert the primary impedance to the secondary impedance. Now ZS and ZP both are the impedance in respect of secondary and primary. Now ZS is Z is equal to V by I. For ZS equal to PT secondary voltage divided by CT secondary current, and for ZP it is equal to PT primary voltage divided by CT primary current. By simplify it, we can get ZS by ZP equal to CT ratio by PT ratio. That is, if we multiply any primary value of the impedance into CT ratio divided by PT ratio, we will get the value of the impedance in secondary. Now to convert the primary to secondary value, we have to multiply the value of zone 1, that is 0.8 into 100 into 0.425 at an angle of 70.75 degree into CT ratio by PT ratio, that is equal to 800 by 1200. That is, by simplifying this equation, we will get the value of zone 1 equal to 22.67 ohm, and time setting should be set as 0 second. That is, zone 1 tripping is instantaneous. Any fault sensed by relay in zone 1 on distance, it will send a trip signal instantaneously. Now what is the zone 2 setting of the relay? Now zone 2 setting for a parallel line or for a 132 kV system is 100% of the line segment plus 50% of the next shortest line. Here from substation B there are two lines, that is, one is 100 km line and one is 50 km line. 50 km line length is the shortest line. Therefore zone 2 setting is equal to 100 plus 25, that is 50% of the shortest line. 50% of shortest, 50% of 50 km is 25 km. That is 100 plus 25 into impedance per kilometer, that is 0.14 plus I 0.0401 into CT ratio by PT ratio, that is equal to 125 into 0.425 at an angle of 70.75 degree into 800 by 1200, which is equal to 35.42 ohm, and time is set as 300 to 350 millisecond. Here the time can be increased depending upon the situation, that is up to 500 millisecond. If zone 2 reach encroach in the next, if the next shortest distance is very less, then zone 2 time can be increased up to 500 millisecond. Now what is the zone 3 setting of a distance relay? Now zone 3 is set as a backup of adjacent longest line setting, that is, in the adjacent longest line for line segment AB is line segment BC, that is 100 km line. That is, from substation B end, if any fault occur in section B to C, if relay at B end fail to clear, then only the substation relay at substation A should operate at zone 3 time to clear the fault. Therefore zone 3 is must cover the line segment, that is line A and B, and the longest adjacent longest line, that is line segment B and C. That is why zone 3 is set is equal to 1.2 times of the line segment plus next longest line. Now if we calculate the impedance, the zone 3 is equal to 1.2 into 100, that is the length of the line AB, plus 100, that is the longest line from the far end substation, that is BC, into the line parameter, that is 0.140, plus I into 0.401 into CT ratio by PT ratio, that is equal to 240 into 0.425 at an angle of 70.75 degree into 800 by 1200, that is equal to 68 ohms, and zone 3 time is given as from 800 to 1000 millisecond. However, if zone 3 reach encroach the next voltage level, then time should be increased to 1.2 to 1.5 second. Next voltage level, we must check whether the zone 3 is encroached the next voltage level or not. Now the zone 3 is set as 68 ohm. Now check whether zone 3 is encroached next voltage level at substation D end, because from the substation B end a shortest line is connected, that is 50 km. Now if we calculate it, the calculation will be as follows, that is we have to consider the 100 MVA transfer impedance and convert it to the primary or secondary value, that is 150 km line length into 0.425 into 800 by 1200, that is the CT ratio by PT ratio. It is converted as secondary value of the transmission line, that is 100 km of the line segment and adjacent line length, shortest line length of the 50 km. Then we have to convert the transformer impedance in the secondary value. Now from the percentage impedance to actual impedance is given by kV square by MVA into percentage impedance. Here HV side voltage is 132 kV and MVA is 100 MVA, that is why it is 132 square into 0.125 by 100 into CT ratio by PT ratio, that is 800 by 1200, which comes as 14.52, and the line impedance is for line segment AB and line segment BD is equal to 42.5. The sum of the line impedance and the transformer impedance in terms of secondary value comes as 57.02 ohm. So we can see the zone 3 is encroach the next voltage level at substation D. That is why the time can be set as 1.2 to 1.5 second, so that any fault in the 33 kV side of at substation D should not operate at zone 3 at substation A end. Now come to the zone 4 setting. Zone 4 is 10% of longest line for line segment and 20% of the shortest line of the line segment. If line length is more than 100 km, then it is set as 10% of the line segment. Since line length is 100 km, we will give the zone 4 setting as 10% of the line impedance in terms of secondary value, that is 0.1 into 100 into 0.1400 plus I into 0.401 into CT ratio by PT ratio, which comes as 10 into 0.425 at an angle of 70.75 degree into 800 by 1200, that is 2.83 ohm. Now the time should be set as 500 to 600 millisecond, that is zone 4 setting is given to cover the fault at main bus end, that is if the remote end bus fail to cover the fault at substation A end, then only the zone 4 relay operate. That is, if fault occur at substation A at main bus, that is the reverse side of the CT, then if there is no bus bar protection, then the relay at substation B end should operate at zone 2 time, that is 300 to 350 millisecond. If relay failed to clear this fault, then only substation end relay should operate at zone 4 time. That is the philosophy of zone 4 time.